Okay, guys, so last week you took your 6 weeks test. So this week we are starting equations. But before we get to equations, we're going to talk about like terms. So we are going to be talking about like terms. You all see that? Now, let me make sure. There. Now you should be able to good. Okay. So we're talking about like terms. In math, you're going to have equations. They're going to have all kinds of variables in them. Okay, so when we're talking about like terms, we do need to do some definitions. So we have the word variable. Well, what is a variable? Well, I am so very glad that you asked me, and I'll be very happy to tell you. A variable is a letter used, trying to make sure I don't, there we go, used to represent a value in a problem. Okay, so it's a letter used to represent a value in a problem. So anytime there's a missing piece, so that's what we're looking for. You will use anytime you are looking for a missing piece. Okay? So that's when we're going to be using a variable. So a variable can be any letter. Normally, in math, you're going to see the letters used most often are X. And I always give them a little curve. That way it doesn't look like a multiplication sign. So if you see a little curve, that's a variable for me. That is not multiplication. You'll see a Y, a Z. We'll use A, B, C. Sometimes we use W. Every once in a while, they'll use S and they'll use T. I try not to use T because too many people think it's a plus sign. I do my T's differently, and that's honestly the reason I started writing my T's this way is because if you write it the way we all learned how to write T's when we were little, it looks exactly like a plus sign. So I started writing my T's this way for when they do use T. But I try to stick with these right here. These are the ones I try to stick with. Okay? Every once in a while, let's take this off. Because every once in a while, you will see, and we will get into this later when we're talking about variations, you'll see the letter K. But that's very, very rare and very seldom that we see the letter K. Okay? So you'll see that. When you get into geometry, you'll see H as well, but we're going to just stick with these for now. So these are different types of variables. Now, when they're talking about like terms, they're talking about the variables that are the same. So they're talking about X's being with X's, Y's being with Y's, Z's being with Z's, and so on and so on. So like terms are anything with the same letters. Any term that has any terms that have, let's change our, have the same letters, which you need to remember are variables, okay? I'm only going to use letters for a few a few times. The rest of the time, I will say variables. Okay, so that's what like terms are. Any terms, oh, I need a Y, don't I? Any terms that have the same letters are variables. So that's the mathematical way to look at it. But before we go any farther into that, let's look at some things in real life that we could use. All right, so we're going to erase this. All right, so what do we've got here? We've got an apple, we have an orange, we have some grapes, and we've got a watermelon. These are all fruits, right? But are they the same fruits? No. Okay, these are all fruits, so we can agree that these are all fruits. Right? They're all fruits. We can all agree on that. We have an apple, we have an orange, we have grapes, and we have a watermelon. They're all fruits. But are they the same fruit? No. They are all fruits, but they're all different. Right? So they're all fruits, but they're all different. Now, the reason I bring that up is because many times what I have seen with my students is they look at variables and they're like, well, they're all letters. Well, yeah, they are all letters. But are they all the same letters? No. If I ask you, oh, they're all fruits, so we can say they're all the same, you'd be like, no, they're not. Okay, it's the same thing with our variables. So if I put an X and a Y and a Z and an A and a B up here, these are all variables, right? They're all variables, but are they all the same? No, they're all different. These are all different variables. They're all different. I can't take all these fruits and put them together into one category and say, oh, these are all the same, right? Just like I can't take all of these letters or these variables and put them into the category and say, oh, they're all the same. They're not. Okay, they are in the same family because they're fruits, but they're not all the same fruit. So that's what you have to understand. That's what we're talking about when we talk about like terms. We would have to have an apple to go with an apple for it to be alike. We would have to have an orange to go with an orange for it to be alike. The same thing with grapes, okay? And the same thing with a watermelon. So when we're talking about like terms, we mean they have to be exactly the same. They have to look the same. Okay? They can't just have a letter and say, oh, they both have a letter. The letter has to be exactly the same. Okay? So if I have this, if I have 4x and I have 3x and I have 2y, and I say, circle the like terms. Okay, circle the like terms. Look at your variables. I have an x, I have an x, I have a y. When you're looking at like terms, they have to be the exact same variable to be considered like terms. So if I say circle the like terms, I'm circling this and I'm circling this. He's not included. Yes, he has a variable, but his variable does not match these. Okay, x's go with x's, y goes with y's. Apples go with apples, orange goes with orange, okay? So now, you're going to be asked to combine like terms. So now, instead of this, what if I have this? And I say combine like terms. I'm still only going to be able to work with the x's because they're the only thing that are alike. So what I like to do is have my students either circle, box, whatever. So now, I know I'm going to have an x. What you do now is you come over here and you say, okay, what's 4 minus 3? Okay, 4 minus 3 is 1. So I have 1x and then plus 2y. This just comes down because it has nothing to be combined with. Now, do I have to have the 1 in front? No. You can take it off if you want. If you don't see anything, it's understood to be a 1. You can leave it on there if you want to. But in your answer choices on a STAR test, you won't see a 1. It'll be gone. It'll just be that. Okay? So that's what you have to remember. 1x is the same thing as x. Okay? These are the same. They mean exactly the same thing. All right? So that is how you would combine the like terms. All right, let's look at another one. Let's say I give you this. If I were you, I would look and I would see what doesn't have anything in common. If there is anything, there may not be. But if I look here, here is a constant. Means it doesn't have a variable on it, but it can still be combined with something sometimes. Okay? I have an x, I have a y, I have another constant, I have a y. Remember what we did at the beginning of the year. We did this. What's the sign on this for? This is a positive, right? What's the sign on this? Negative. What's the sign on this? Positive. What's the sign on this? Negative. What's the sign on this? Negative, right? I still want you doing this, especially on these. But I want to add one thing to it. There's no variable here. Okay, there's no variable, so we're not going to put anything up there with it. We're going to leave it just a positive number. This is a negative x. This is a positive y. This is a negative constant. So again, there's no variable with it, so I'm not going to put anything. This is a negative y. Now, if you look up at this line, you can look right now and you know what can be combined. So this goes with this. Oh, can you see my line? There we go. Why? Because all they have are signs, right? There's no X, no Y, no nothing else with it. Those go together. So I'm going to bring it down. And I usually have my students do this in steps. So this is a +4, and I have a -8. Bring your signs with you. Okay, bring your signs with you. Now, remember your sign rules. I told you they were going to be here forever, right? When my signs are different, what operation do? I subtract. So I'm going to subtract these two. So 8 minus 4 is 4. Now, which is bigger, the 4 or the 8? 8 is bigger, so that means that I take its sign, which is negative. So I have a -4. So this is my first thing I'm going to do. So I did it right here. Okay? Now, do you see anywhere there's another X? I don't see any other X's up here. Do you? So this is going to be 2. I'm just going to bring it down. Bring it down as it is. It's a -3x. And you can circle it if you want to, whatever. So I have -3x. Now, I have y and a y. So those two are like. They are like terms. So they've got to go together. So they are going to go together. So this is my step 3. Bring them down as they are. This is a +2y. And remember, bring your sign with you, so it's positive. This is a -5y. It's negative. This is where we would box if you need to. Make sure you box the sign with it. You don't have to if you're going to do all this up here, but if it makes it easier, then do it. But this is why I like colors. I change up my colors a lot, and this is why. Okay, we know we're going to have a y. The y is not going to change. It doesn't go anywhere. Now, my signs are different, so that means I subtract. So 5 minus 2 is 3. Now, which one's bigger, 2 or 5? 5 is bigger than 2, so we take its sign, which is negative. So that's a -3y. Now, I have combined my like terms. Here's what I've got. Now you've got to write it back together. So I have -4 minus 3x minus 3y. Okay? So that would be combining like terms. And that's a really long one. I did a really long one. I'm going to do one more. I'm going to do a fraction one. But I did a really long one to start with. But guys, you're going to have to take your time and you're going to have to do it in steps. That's all there is to it. It's going to be very important that you understand this. Okay? It's going to be very important. Okay. All right, I'm back. They were checking on my Promethean board. So we should be able to use it soon. So that'll make things a lot easier. Okay, so now let's do some fractions because we love fractions. Miss Long keeps dropping her pen stuff. Okay, so we're still combining like terms, but now we're going to do fractions. So let's do 1/2 a minus 4 plus a. Okay? 1/2 a minus 4 plus a. What's my sign on 1/2? Remember, if I don't see anything, it's understood to be positive. This is negative. This is positive. This is an A, nothing, A. So there's only two things I have to combine here, right? It's these two pieces right here, the only two things that get combined. That's going to be step one. So I've got 1/2 A plus A. Now, what did I tell you a minute ago? I told you that this was the same thing as this, right? So that means that this is the same thing as this, right? Why is that important? Well, we're dealing with fractions. Remember, we have to have common denominators. So I'm going to write this like this. Remember, I told you last week, anytime we have a whole number, which we have a 1, that's a whole number, there's an understood 1 under it. Now, to get a common denominator, Miss Long calls it crisscross. Remember, we take this 2, and we know that we're going to multiply the denominator, so we have to multiply top and bottom by that 2, right? What we do to one side, we're going to do to the other. But the difference is we're going to multiply by 1. Okay? So now, we have 1 times 1, which is 1. We have 1 times 2, which is 2. So we still have 1/2 A. That one didn't change, did it? Plus, we have 1 times 2, which is 2. We have 1 times 2, which is 2. So 2 over 2A. Remember, the whole point was to get this piece right here to be common, to be the same. And remember, when we are adding fractions, that denominator does not change. So bring it over here. My denominator is going to be 2. Now I have an A. Now we add our numerators. What's 1 plus 2? 3. Can I leave it as an improper fraction? Absolutely not. Okay? This is where some of us still had issues even on our 6 weeks test. Okay, so remember, we divide. So 2 goes into 3. How many times does 2 go into 3? Goes 1 time. 2 times 1 is 2. Have 1 left over. But remember, we're not talking in remainders anymore. Remember, whatever is up here, this is your whole number. Whatever is here that used to be your remainder is now your numerator. And whatever's out here, which is also called your divisor, is now your denominator. Okay? So 3/2 A is the same thing as 1 and 1/2 A. See? 1, 1/2 A. Okay, so this was step 1. Now, step 2 is just going to be to bring this down. I'm going to move my camera down a little bit so you can see. So I have 1 and 1/2 A. And now all I got to do is bring down this -4. Oh, you can't see it. Whoop. We're literally going to bring it down. So it's that -4 is going to go down here. So -4. And that, my dear friends, would be your answer. Okay? All right. We're going to do more in class. We're going to do more with a Loom video on the sheet itself. So make sure you watch those. Make sure you're in class so you can get some more examples. All right. We will start one-step equations tomorrow. Bye, guys.